One of the things that you really have to realize is the speed of light is very, very special. It's not just simply a speed of something moving through space. As you go faster and faster and closer to the speed of light, time itself begins to slow down. And space begins to contract. As you go close to the speed of light, the entire universe becomes smaller and smaller until it basically just becomes a single point when you're going at the speed of light. And time, as you go closer to the speed of light, gets slower and slower until basically time is a single point at the speed of light. Light does not experience space or time. It's not just a speed going through something. All of the universe shifts around this constant, this speed of light. Time and space itself stop when you go that speed.
Hello, you are welcome to another exciting episode of Beyond Indoctrination, and we are discussing something very fascinating about the universe and its relationship to us as a species, and some cool facts that you may be knowing the first time. How vision is caused basically is that the object is able to illuminate light that hits your retina, and then the brain interprets these signals that have been taken by the retina and interprets them into vision.
Then, the lens moves light through the clear cavity called the vitreous and focuses it on the retina. The retina then converts this light energy into electrical impulses and passes it through the optic nerve, also called the second cranial nerve. These impulses then travel through the optic nerve into the primary visual cortex, which is located in the most posterior portion of the brain's occipital lobe. While it may sound like a lengthy process, but takes only about 13 milliseconds.
They are all basically light. That is why when you are in the dark, you don't see anything, because there is no source of light, or there are no photons that are hitting the object to bounce onto your retina for you to be able to see. Basically, that is how vision is caused. Light actually moves at the universal speed limit. The universal speed limit is also the limit that all weightless objects move. Okay, so photons are weightless and quarks are weightless, and then the gravitational waves are also weightless. So no object with mass can move at the universal speed limit. That is also the speed of light, as we call it. It can also be called the speed of gravitational waves as well, because they don't also have any weight. Albert Einstein proved it in his theory that no object with mass would be able to move that speed. So of course, light is very fast. It goes from the moon to the earth in 1 second. Actually, the moon is really far away from us. The distance between the moon and the earth can fit 30 earth-sized planets. Okay, so it could tell you how huge it is, even though it is the closest celestial object to us. So light is a very fast object, especially when it comes to our domain. And then you could appreciate the fact that when you switch off your bulb, okay, the light actually moves from the bulb to the corner of the room, but it is so fast that your senses cannot comprehend the motion. So if you have a way to be able to slow it down extremely, you will be able to realize that the light moved from the bulb all across the room to the corner of the room. So it means that if you're able to slow it down, you will see the motion of the light, that it moved, covering spaces till everywhere became bright. But I don't know if there is such a tool yet because the speed of light is very swift. In the dark, if you light up your torch, before you could realize it is on something that you actually projecting the light on, but actually it moved there. So that is how quick it is. But when you are considering how we see objects from space, it is different when you understand the distance it covers. We know that light takes 8 minutes and 20 seconds from the sun. As we are here, we are seeing the sun as it is 8 minutes and 20 seconds, which means that even if the sun were to disappear right now, it will take 8 minutes and 20 seconds for us to even notice it happened, because it will take 8 minutes and 20 seconds for the last bit of light that left the sun to actually reach us. So take the sun as a source of light and then picture it as though it has been turned off. But due to the distance that it will take to reach us, the last bit of light that left the sun is going to take 8 minutes and 20 seconds for us to even notice that it left, because that is the distance light covers to reach us from there. And if the sun were to disappear, all the planets will fall away without having nothing to revolve. As we all know, all the planets are moving around the sun in the sun's gravitation. If the sun is no more, we won't be able to, you know, rotate nothing and we just fly away into space. But we won't realize that instantaneously because the gravitational waves also moves at the universal speed limit. If the sun were just to disappear, we'll be orbiting nothing for about 8 minutes and 20 seconds before we actually fly away into space where everything will go chaos. And the reason is that the gravitational waves also move at the universal speed limit at the same time. That is the way the light also moves. So it means that we'll fly off into space at the same time everything will go dark. So it means at the same time when everything goes dark, that's the same time we'll all just fly away into the cosmos with everything going chaos and the planet just moving around like throwing a ball around in an empty space. Yes, so that is the property that light and the relationship it has with us. But this is just 8 minutes and 20 seconds from the sun. Now, considering objects like galaxies that are millions of light years away from us. So, for example, the closest galaxy to us is the Andromeda galaxy, and it is 2 million light years away from us. 2 million light years away from us. So take the bulb in your room, for example, as Andromeda galaxy, and take one corner of your room as maybe the Milky Way galaxy where we are, or take the corner of your room as let's say Earth, okay, and then take your light bulb as the Andromeda galaxy that is closer to us. It means that when the Andromeda galaxy was formed, that is when you on the light. It actually took 2 million years for the light of the bulb in your room to actually reach the corner of your room where you identify as Earth or the Milky Way. That is how light within space can actually take long. It means that when the light from Andromeda galaxy left, humanity was not even a thing on the planet. This is how fascinating the universe can be. And then as we are seeing the Andromeda galaxy, we are seeing it as it was 2 million years ago, which means that if the Andromeda galaxy disappears today, it will take about 2 million years for us to even realize that it is not there. For example, light from your bulb. takes 2 million years to reach the corner of your room where you identify as Earth. If you put off the light again, it will take about 2 million years for the last bit of light to actually be noticed at the corner of your room to actually go dark. That is how interesting the universe can be.
I want you all to close your eyes and truly grasp the idea of time. We must take a step back and ask, what is light? So journey with me to the sun. Light travels from the sun to the earth through space. Yes? Now is your age. I wanted to know, how can something light travel through nothing, space? Let us isolate a light beam and travel alongside it. And let us go faster. Faster. What is time?
Then now consider the fact that other galaxies are farther away. This should tell you the distance that light has to cover, which is in fact the fastest thing in the universe, had to cover in such enormous spaces to be able to reach us. So when we are looking into the night sky, all the objects we are not seeing them as it is, we are seeing them as it was. Okay, so if there is an alien who is probably about 2 million light years away from Earth, they are probably seeing the Earth 2 million years ago because it takes that long for the light from Earth to actually reach them. As I said in the beginning, the vision is caused when light hits the retina from the subject or the object. If you are to observe a planet, you are supposed to see it, and then you see it when the light source from that planet hits your eye, and it is not hitting your eye on the go. It has been traveling across a space. So which means that if there is a planet that has just been formed now, about let's say 100,000 light years away, the light will not reach us today. The light is still traveling. Even though it is formed today on this second, we are not going to notice until the 100,000 light years reaches, because that is how long it will take the speed of light to move from that planet to what Earth.
We all know that light travels in vacuum at an incredible speed of about 300,000 kilometers per second. This is also considered the cosmic speed limit. Although the speed of light is extremely fast, it is not infinite. This means that it takes time for light to travel from one place to another. So due to the finite speed of light, did you know that if aliens were living 80 light years away from Earth and they pointed a telescope at our planet, they would see World War II still happening? That's because the light from the war would have taken 80 years to reach them. In the same sense, if aliens were living 65 million light years away, they would see dinosaurs still roaming the Earth.
In this knowledge, if there is a giant mirror that can be viewed from Earth that is so farther away, like 100 light years, it means that it will take 100 light years for what is happening now to hit the mirror. Okay, for the mirror to reflect what is hitting it back onto Earth. So it means that what we are doing today won't be seen on the mirror, but people of the future, about 100 light years from now, would be able to observe what is happening on the mirror. It's very interesting. And what they are also doing won't be seen by them, will also be seen by a different generation, because it will take light this long for it to actually hit the mirror and then for it to reflect back here for people who are there in that generation to be able to see. Like to open up the discourse to. So it's a really interesting dynamic, and the universe is an interesting please, if you really understand how it works,